Hi and welcome to this small overview of this pack, and I'm going to show you a few key elements that you are getting with this and how to use them, breakdown of the systems and what different variables are doing and stuff like that. These systems should be pretty easy to use, and I'm pretty sure that they will be a huge boost for workflows. And the main idea is also to generate something that is both visually good looking and performance-wise also pretty clever. So let's get started. So first things first, in order to avoid issues and use all of the features that this pack can offer you, you should enable the following settings. So in the project settings, you should enable generate mesh distance fields and debuffer decals. Some word of caution. Make sure you are not manually copying files with File Explorer, but instead use the migrate workflow. This way you will avoid possible issues that might occur if you move files outside of Unreal Engine. And if the editor asks to import files, always choose Don't Import. This is because the pack contains source files for those who like to edit them, and importing them again might reset some settings and cause issues. Just remember that this pack will not work well with static lighting because Blueprint's assets are generating instance mesh components that are not supporting baked light maps correctly. And if you want to edit these blueprints, just remember that some of them might be very advanced, so in order to edit them, you should have a pretty good understanding about the Unreal Engine blueprint system first. The first thing is the building system. Now this is maybe the largest part of the pack, and it is being used for buildings and even sidewalks and ground itself. So there are a lot of things to cover, so let's get started. Building system is constructing buildings using different building library sets. These sets contain building meshes that are modeled in a modular fashion to work well together. Currently there are 8 different style blueprints with over 100 variables to change. This way you can control building size, colors, damage, windows, roofs, doors, and so on. Blueprint will then use hierarchical instance static mesh components to construct the actual building in an optimized way. You will also have an option to make it generate static meshes instead. This will have a huge performance impact in terms of draw calls. Main logic is the building parent class. Every building is then inheriting that logic from this class. Some common variables are public, so you can tweak them in the level and create more variation between buildings. Others are private that you need to change inside that child blueprint. Most of the time you don't need to do that unless you are creating new ones or want to make changes to each building instance. The system is divided into different parts. First stage is the planning stage. In this part of the system we'll calculate building dimensions and generate bounds that are later used for the actual building process. Turning that on will make it faster to work and edit buildings, but you want to change that to false when you are done. This will then run the actual logic that generates histons and assign materials. In the same place you can find variables called floor amount, height and long. These are used to control the building dimensions and are the most important variables in this system. Everything else is then created based on these variables. Seed number is a handy way to generate different variations and keep those changes using a pseudo-random logic. It will affect every random function that the system uses. This seed number is also changing based on the building world location, so every building can be a unique one to each other. When bounds are calculated, the next stage is actual wall building. This is done for left, right, front and back sides, and you can find control for each side under Control tab. You can choose to disable construct on specific sites totally, enable, disable windows and so on. These settings are the most used ones and have a huge impact on how the building looks. There is also a separate control for the first level. Door offset controls the door building position that is different for every building due to the different building dimensions. Then there are controls for roofs, and you can disable roof construction or choose to scatter roof decoration that are specified under Meshes tab. If you wish to change settings related to constructing sidewalks, you can do that also. This system will construct sidewalks using the building dimensions, and then you can specify multipliers that will shrink or grow that system. On top of this, you can also choose to spawn light bulbs and controls how often they are spawned. there is also an option to spawn actors on sidewalks. You can specify those actors in the sidewall actors array, and then the system will choose actors randomly based on that. Changing the seed number under control will choose what actors are placed and where. This is a good way to generate desired outcomes. Some buildings can also have interior parts that are generated after the main building generation part is done. This function will add floors and set up some interior volumes to handle interior post-processing and checking that make sure when the player is in or out of the buildings. Scattering settings are controlling different layers of meshes that are scattered on top of buildings. You can choose to enable the system for walls, sidewalks, roofs and floors. Every layer is using the same structure variable. You can choose to use random rotation, apply different scales for scattered meshes, change culling distances, scatter density and even collision setting. The system will look for meshes from the scattered mesh array and randomly choose different ones and put them into correct isms component to save draw calls. You can simply drag and drop meshes and you don't have to worry about mesh instancing. For example, you can spawn some air pumps on walls with a specific scale and density, and then spawn smaller debris on sidewalks with smaller scale without any collision, random rotation enabled and smaller culling distance, and maybe even larger scatter density. This way you can add lots of details with minimal performance impact and still have enough control. You can also opt to use mesh socket-based scattering. You can specify a mesh array and some basic control like min and max scale and so on. You can edit, add and remove a mesh socket simply by opening the static mesh and display control where to spawn those instant meshes. This is perfect for scattering things like ivy, hanging foliage and such. Buildings are using materials that are specified for that building type. You can however change those if needed under materials. Under amounts you can find settings to control the amount of damage and dirt buildings can have. Even though this building system is optimized, it's not optimal to use this for faraway cityscape. If you need to add distant cities, then you can use the bb_distant buildings blueprint. It will scatter merged building meshes and randomly choose different building colors using material functions. These merged buildings are usually costing only a few draw calls, and the system is also instancing these meshes, so it's possible to create very large cities for background use with minimal performance footprint. Merged buildings are low poly meshes and are using low resolution textures, so they are not optimal for situations where players are able to get very close to them. And if you want, you can create custom building meshes to be used with this building system, but it would be a good idea to create a new child blueprint in that case. This project is heavily relying on the dynamic lighting with distance field shadows and AO. So make sure to enable generate mesh distance fields option in the project settings. bb_environment controller is then changing light values based on the time of day system's clock values. If you want to manually change light colors, then you can either disable the control active boolean variable or even open the bb_environment controller and tweak values there. You can also replace this controller with something else, so it's safe to remove it totally. But just remember that if you still want to change material wetness values, then you need to edit corresponding material collection parameters. bb_car blueprint will allow you to easily generate different vehicle variations. There are also separate blueprints for versions that allow you to open and close doors. So random color, basically when it's enabled, it will use random colors that are stored in the car color array. You can add and modify colors there. When random type is true, it will randomly choose what car type the blueprint will be using. Random dirt amount will randomly choose a different dirt level and amounts. Allow foliage is controlling whether or not the car will have foliage on it. You can also spawn these cars with the foliage paint tool. Simply navigate to Blueprints and Vehicle folder and find an actor called pb_car_painted. You can now drag and drop that into the foliage painter window. After that you can select it and start painting. By default, all of the car actors will be using random functions, so every car should look a bit different. Now this way it's possible to add cars easily. Spline blueprints are inheriting main functions from bb_p_spline class. This system is using a spline curve to spawn different type of meshes. This system can be divided into different parts, and it's possible to use all of them at the same time to have a very advanced system. Spline meshes are basically the main one that this system is going to use. This way meshes will deform and follow spline curve accurately, but you can read more about this system in here. Spline mesh array will store meshes that are used for this system, and you can specify them as much as you need. Spacing will control how many meshes that the system will place along the spline. Using 2 low values will stretch meshes and 2 high values will flatten them. Tangent scale will control the overall smoothness of the curve that we use for these meshes, but usually you want to keep this close with the spacing value. Keep in mind that spline meshes can increase your draw cost dramatically. The more spline meshes you use, the more draw cost it will generate. Using instant meshes is a more optimized way because then we can batch meshes better. Unfortunately, systems are not supporting mesh bending in the same way that spline meshes do. However, there are lots of cases where we don't need this. Then systems are a more optimal choice. You can find similar settings here like those that we use for spline meshes. You can enable or disable this function, specify what meshes to use, random order to use these, and so on. Then there are some settings to control rotation as well. Cutoff settings allow you to cut instances from start or end spline points. This is useful when there are unique meshes in the start and end points, and we don't want to add HISMS instances on top of those, just to avoid z-fighting and so on. HISMS scale will help to fill gaps in the cases where the mesh length will not match with the spline length. When the settings is true, the system will scale the first mesh to fill this gap. HISMS planar constraint setting will constrain HISMS instances onto a plane. This way it will keep Z location the same for every instance, suitable for situations like roads, ground, floor, and roofs. You can also spawn actors along the spline. These settings are most identical with HISMS settings, and there is an array where to specify actors to spawn. An actor spacing value will control the density of how often these actors are spawned based on the spline length. Debris spawning is also supported, so you can specify scattering meshes array, and that will contain meshes that are going to be scattered. Debris spacing value is controlling how often the scattering will happen along the spline, and scatter density will control the amount of meshes that are spawned when that happens. Scatter dimension will specify how large the scatter area will be, and scatter distance is controlling how far traces are going to go. This system is creating HISMS under the hood to optimize performance footprint as much as possible. If you need to add supporting pillars, you can turn the use pillar option on. This system will trace lines from the locations that are taken from the spline based on the pillar spacing value. You can also have extra control to specify whether or not to use end and start pillar. Start offset will allow the pillars to move up and down from spline, and pillar fill offset is used to control mesh scaling to avoid gaps or mesh overlapping. Spline system also includes the same mesh socket based scattering system that is also in the building system. So you can specify a mesh array and some basic control like min and max scale and so on. And the system will then check for each HISM components to see if that contains any mesh sockets. If that's true, then the system will start to generate instant meshes into those socket locations. And like with building meshes, you can edit, add, remove these sockets simply by opening these static meshes. So as you can see, you can use splines for lots of different things, and it's basically just an input for this system. You can expand these systems even more if you so choose. Scattering blueprint BB_B scattering is basically using 2 different systems to find transforms where to add instance meshes. These systems are line trace based and plane based. Line trace based is more accurate but will be a bit slower to update when changing values in the editor. Line space will just take random points from plane and will ignore the actual environment. This is faster and works well when you need to scatter something on flat surfaces. You can change between these 2 modes with a constrained plane mode variable. Calling distance is controlling when to call mesh instances. Smaller values means that instances will be called faster, and a value 0 means instances will not be called unless calling volumes or system similar to that calls it. Scattering meshes array will be used to figure out meshes the system will scatter, and it will automatically create systems components for each unique mesh type and then store the same type of meshes there. This will keep the struggles at minimum. Scatter density will control how many times the system will run its loops and scatter meshes. Scatter type enum controls how to align meshes on the surfaces. Scatter dimension vector variable is specifying the actual scatter area where the system will take points for tracing. You can also change collision settings whether or not to use collision at all. Instance meshes need to be constructed every time the level loads, and this system also uses pseudo-random function for that. Remember that you can also use this blueprint as a child actor. You might have noticed that this pack also features a lot of different foliage types, and maybe the largest one of them are the trees. Each tree will use 4 different LODs, where the last LOD is just a simple billboard. In the example map, these trees are placed using the foliage painter tool. Grass and smaller foliage is using the landscape grass system, and you can tweak these individual landscape grass types to have better control for scale, density, and lighting settings. You can find more info about this in the Unreal Engine documentation. This pack also comes with an example player blueprint. It is based on the basic Unreal Engine first person pawn with some small changes like an option to switch between first and third person views. It will support basic movements, crouching, and even car driving. So in this case, you can find this pickup car and enter it. And after that, the Unreal Engine position system will take control and you can drive it around. And there are some control, so you can actually toggle headlights on and off by using a Q. And obviously you can change it later on, but by default it's using that. And all of this is based on the physics car class. You can read more about this feature in the pack documentation, and the link is in the description below. So these are the basics, and if you still have some questions or even some feature requests, feel free to send them to me or leave a comment below.